Okay, what we have here is the beginnings of a brushless motor, a brushless electric motor that uses 3D printed parts for the housing and the stator, the top part. You'll see that this has 6 screws for the stator windings. This stator already has a 4x8 by 4 millimeter bearing top and bottom, so this 5/32 brass shaft spins very freely. Notice also the base mount is conveniently printed with that stator. This is going to be the rotor. You can see it already has 2 magnets installed, as well as the screws up here on the top will hold this top piece. There's also, a little hard to see here, some black set screws on both sides here that have been tapped in with a 2 millimeter thread. They'll screw tight onto the brass shaft so this spins the shaft as needed. I decided to go ahead and print these blue rings here. Since as this spins, the magnets will be trying to fly out, and I thought maybe some additional support would be warranted. I haven't glued this one in yet. You can see that that's a nice beauty of 3D printed parts. The accuracy of what can be printed is pretty amazing. This top part has a nice feature in that it has a threaded nut where I can thread on a propeller or some other means of measuring the RPM of the motor. I'll control the motor with this speed controller, which provides pulses into the 3 brushless motor inputs. The Arduino microcontroller back here will be used just to provide the pulses to the input to the speed controller. And this is obviously the magnet wire that will be on the stator windings. So that's it for now. I'll provide some more updates as this progresses. Okay, we're back. You can see there's fewer parts on the bench. I've got the stator completely wound. Each one of these windings is the same direction. They're all the same. You can see there's a wad of 12 wires coming down here. When it's all wired up, 3 of them will come out as inputs. Another 6 get connected so the coils are in series, and the other 3 get tied as a common connection inside the motor. That'll be the next thing I work on this assembly. I've installed all the magnets on the rotor, and I've been using this magnetic prop balancer to optimize the balance. It was pretty bad initially, and I've glued in some steel pins on one side. I have to say it's not perfect, but it's a lot better than it was. It's kind of hard to get a round object like that perfectly balanced. I suspect that's good enough, and when we run the motor, we'll see if it's running smooth. So that's about it for now. I'll be wiring up this wad of stuff, and then it's a matter of doing the final assembly and doing some tests. Okay, we're back again. I have this 3D printed motor fully assembled. I've mounted it on a piece of wood and tilted it at an angle so that you can see it while it's spinning. The speed controller has been mounted to the board, as well as the Arduino microcontroller that you see here. The speed controller is this colored wire. That's also how this board gets its 5 volts power. This black wire I've added is in addition to the 3 wires that you see up here that are typical of a brushless motor. Those there's a set of 4 wires that run into this black one here to light my RGB LEDs, which is a unique feature for a brushless motor. Off to the side here I have a watt meter that I'm going to turn on, and will describe the incredible inefficiency of this motor due to the stator windings on a screw and the tremendous eddy currents that have been created. So let's go ahead and turn this thing on. And I'm going to try to kill the lights here so that you can actually see the LEDs better. I think they're showing up fairly well. And then I'm going to try to spin it up here a little bit. So you can see the motor is running very smooth. In fact, when it's running, you can see right through the top case and see the 6 stator windings inside, depending on what LED color comes up. They're randomly selected by the Arduino. So wow, it runs. I stated there was an issue with the power dissipation. I'm going to go ahead and turn the lights back on. And over here on the watt meter, I'm showing volts right now, which is the battery voltage. It's a 2-cell LiPo, nominally 7.6 volts. I'm going to switch that to, there's the amps, I'm going to switch it to power. And that's the rather shocking result right there at 4.5 watts. We're doing no work. This is just a flat blade piece of wood, and it's already burning 4.5 watts. And if I turn it up, you see those wattage numbers grow rather dramatically. So all we're doing is generating a lot of heat on the stator windings, which obviously makes me rather nervous because those are just screwed into 3D printed plastic, and if they got too hot they would obviously melt and the motor would self-destruct. So there's an opportunity for improvement. I basically have 2 opportunities. The first is to eliminate the metal screws that are enabling very high eddy currents. I think anybody that studied physics or electronics has been through that eddy current discussion, and I knew I would have some. I had no idea they would be as severe as they are. The other opportunity I have is that I used 20 gauge wire up here on the motor, and that's way too fat. I was only able to get 35 turns on each stator, and that means I'm spinning the motor a lot faster than I'd like to. When I build another one, I'm going to at least double the number of turns, and that should make the motor run basically half as fast. I'm not looking to make a real fast motor made out of plastic. And then to eliminate the eddy currents, I did some research on that, and I found that one of the best ways of making an electromagnetic magnet is to use ferrite cores. So I've actually sent off on eBay from a Russian supplier to buy some ferrite cores that I'll wind the stators on, again with a thinner diameter wire. I'll end up using the same rotor that I have here, and I'll just print a new stator base back here and be able to reuse this whole assembly, with the only thing being new is the stator base, ferrite rods, and a new set of windings. So that's it for now. Maybe in another few months I'll have a follow-up video of this to show that we're much more efficient than we are today. Thank you.